Hi, grade 11. Let's continue talking about the voltaic cell, okay? Today, we will talk about another type of electrochemical cell that known as galvanic cell, okay? Galvanic cell is a type of voltaic cells, and it's defined as device use chemical reaction to create electricity, okay, especially an oxidation reduction reaction, which known as redox reaction to create electricity, okay? And we use these cells in our daily life because a battery that's used to operate many devices in our daily life is an example of galvanic or voltaic cell, where the chemical inside batteries react together by oxidation reduction to produce electricity to can operate in the power cell phone, torchlight, and other different equipments. What the structure of galvanic cell? Okay, galvanic cell composed of two beakers, okay, and in the first one we dissolve zinc sulfate to make aqueous solution, and in second one we dissolve copper sulfate to make aqueous solution, okay? And we use two different metals to make the electrodes of galvanic cell. In case of zinc sulfate, we immerse it a zinc rod, okay? And in second beaker that contain copper sulfate, we immerse or dip copper rod, okay? And after that, we connect between two rods by using metal wire. Also, we use another structure inside galvanic cell known as salt bridge, okay? So, what's the idea of its operation? The operation of galvanic cell depends on the electrons begin to move from zinc rod to copper rod, okay? Why? Because zinc is more reactive than copper according to chemical activity series, okay? So by moving electrons, we can generate electricity because electricity depends mainly on the motion of electrons, okay? So, and to detect the passing of electricity through the wire, we can use electric lamp, okay? And this is part of the galvanic cell. Look at the screen. This is part represent the electric lamp used in galvanic cell, okay? The lamp, after passing electricity, will illuminate or light up, okay? So, to explain the chemical reactions occurred in galvanic cell, okay, or voltaic cell, where the galvanic cell have another name known as voltaic cell, okay? In the first beaker, what happened? In the first beaker, this is a first beaker. We have zinc atoms that covered the zinc electrode, and also we have zinc positive ions formed due to the ionization of zinc sulfate, which used as an electrolyte in the first beaker, okay? And also in second beaker, we have a copper atoms that cover the copper rod. And also we have copper positive ions that formed due to the ionization of copper sulfate, okay, that used as an electrolyte in the second beaker, okay? And the wire connected between zinc and copper electrodes, okay? What happened during the operation of galvanic cell? The copper positive ion has a strong pulling force for electrons, okay? So copper positive ions can attract more electrons, while zinc has a weaker pull for electrons, okay? So each zinc atom found in the first beaker began to lose 2 electrons, okay, by oxidation and change into zinc positive ions, okay? And the electrons liberated from, okay, the oxidation reaction begin to flow through the wire and reaching to another electrode, okay, to reach to the copper positive ion that formed from ionization of copper sulfate, okay? Copper positive ions are characterized by having a strong ability to pull the electrons, okay? So, we have a rule. Always the neutral atoms of metal make up solid metal, okay, found in solid form. But if the solid metal atom, neutral atom, losing electrons and changing into metal positive ions, okay, they can usually dissolve in water. Okay, and formed in aqueous solution, okay, inside the aqueous solution. So the copper positive ion that formed due to the ionization of copper sulfate began to reduce and gaining electrons, okay, and change into copper neutral atoms, okay. The copper neutral atoms deposit on the copper rod in the galvanic cell, and by passing the time, zinc rod erodes, okay, and its size decreases due to the oxidation of the zinc atom and changing into zinc positive ion, while copper rod, its size after passing the time increases gradually, okay, and this is caused after the time the running out of the reactant necessary for creation of electricity, okay. So we have two processes occurred, two chemical reaction occurred in galvanic cell: reduction and oxidation. Reduction mean, as we know, gaining of electron, okay, and this is type of reaction occurred at cathode, okay. What happened at cathode? Cathode represented a copper rod represented a cathode or a positive pole in galvanic cell. What happened in this type of electrode? Copper positive ions reduced by gaining two electrons and change into copper neutral atom in solid form that deposit on the surface of the copper electrode, while oxidation process occurred at anode, okay. What's meaning of oxidation? Oxidation, as we know, is losing of electron, okay. So what happened? The anode that's made up of zinc rod, okay, and represented the negative electrode in galvanic cell. What happened? Zinc neutral atom oxidized by losing two electrons and change into zinc positive ions plus two electrons, okay. So H beaker has a half equation, okay, and the net equation of the galvanic cell: zinc, okay, neutral atom plus copper positive ion, arrow, after the arrow, zinc positive ions dissolved in aqueous solution, and the copper neutral atom found in a solid form deposit on the copper electrode, copper surface electrode, okay. So we use a salt bridge, as we see in the figure in front of you. We use a salt bridge. The salt bridge in galvanic cell containing another ionic compound, sodium chloride, okay. A salt bridge used in this type of electrochemical cells to connect between oxidation and reduction half cells, okay, of the galvanic cell, and also it maintains the electrical neutrality within internal circuit, electric internal circuit, okay. Thank you, grade 11, and goodbye.